And these are the certain similarities of the sapwood and heartwood, that both comprise of secondary xylem and both derived from the cambium vascular bundle, and both offer mechanical support to the tree. And this picture shows the different parts of the tree trunk. How the percentage of sapwood and heartwood is determined? Here is the simple formula. Like we cut the tree trunk and take the disc, and then we have to calculate the area of the heartwood present in the tree from the disc, and then total area of the disc need to be computed. And using this formula, we can calculate the percentage of heartwood which is present, and similarly we can calculate the percentage sapwood which is present. Then we have to calculate what is called the heartwood ratio. The percentage of heartwood divided by percentage of sapwood will give the heartwood sapwood percentage ratio. Here, this table gives the percentage of heartwood and percentage of sapwood and heartwood-sapwood ratio for different agroforestry tree species. So the age of this tree was around 20 to 22 years, and we can see the amount of heartwood or the percentage of heartwood which is present. It is very much dependent on the age of the tree and the tree species and the condition in which it is being grown. So many factors determine the percentage of heartwood and sapwood present in a particular tree species. So here we can see that in case of teak, the percentage of sapwood was around 42%, and heartwood and percentage of sapwood was also around 42%, and the sapwood heartwood ratio was around 0.98. So this type we can determine by destructive method, by cutting the tree and then determining the percentage of heartwood and sapwood from the tree disc. But later, one presentation is there for ERT, which is going to determine the percentage without cutting the tree. That is called the non-destructive technique for determining the percentage of heartwood and sapwood in a tree. Here, the commercial tree species like teak, age-wise, how the percentage of sapwood and heartwood is going to change. We can see here from 1 to 10 years, the average percentage of sapwood was around 90%. More amount of sapwood was present compared to heartwood, which was around 9%. In another age class, 11 to 20 years, the amount of sapwood was reduced. It was reduced to around 66%, and heartwood percentage increased to 33%. So we can see here as the age of the teak increased, the amount of sapwood was keep on reducing, whereas the amount of heartwood was increasing, and it becomes when the tree age was 70 to 80 years age, the percentage of sapwood was around 10%, whereas the heartwood was around 90%. So this is how, when we keep the tree for longer duration, the percentage of heartwood, which is valuable part of the tree, will increase. And then we can see the difference in the mechanical properties of the sapwood and heartwood in case of teak. So there are three different properties which have been compared based on the age of the tree. It's a density, modulus of rupture, that is bending strength, and modulus of elasticity, that is bending stiffness. So when this tree age increased, we can see the density was also increased for both sapwood and heartwood, but heartwood density was higher compared to sapwood in most all cases, and similarly the modulus of rupture, that was also increased from 50 In case of age, when age group was 1 to 10 years, the sapwood has the MOR around 50 to 52.7, whereas the heartwood MOR was 80. Similarly, MOE was not much difference. MOE was almost the same between sapwood and heartwood, but strength was pretty high in case of sapwood. But when the tree age increased from 21 to 30, the difference between the sapwood and heartwood strength was almost nil. There was not much difference. Now, this just shows how between sapwood and heartwood, the MOR and MOE is increased from sapwood to heartwood for a certain duration, age, and then it becomes stagnant. And this is a scenario for the Indian teak. Here, the sapwood, heartwood, and their significance. We can see here the specific gravity of the sapwood was around 0.46, whereas the heartwood was 0.49. So heartwood density is greater than compared to sapwood. Whereas the modulus of rupture, MOR, it was no significant difference between the sapwood and heartwood. And maximum crushing stress, this is another property where we are going to apply the force along the fiber direction. So this was also significantly different in case of heartwood. It was 362 kg per centimeter square, whereas sapwood it was 298. So there was a significant difference between the sapwood and heartwood. Similarly, the Charpy impact bending value, it was also significantly different in case of heartwood compared to sapwood. Heartwood was much higher compared to sapwood. Similarly, the hardness. Hardness is very much important property, particularly when we want to use the wood for flooring and similar applications. So this was also in case of teak heartwood, the side hardness was 278 kg, whereas the sapwood hardness was 227 kg. So there was a significant difference between the sapwood and heartwood. So we can just see the other important commercial species like Albizia lebbeck. This is another wood species. Here also, there was a significant difference between the heartwood and sapwood of the different properties like static bending, modulus of rupture, maximum crushing stress, Charpy impact value, and side hardness. Heartwood values were much higher compared to sapwood values. And this table shows the Albizia sisu, that is sesame. Sesame is another wood which is being used for different applications, starting from construction and furniture. So many other applications for sisu is being used. So here also there is a lot of demand for the heartwood because heartwood properties are slightly better compared to sapwood. So in case of teak, specific gravity and strength properties of the sapwood are uniformly lower than that of the heartwood, as we have seen in the table. The difference are significant in all properties except bending strength. So bending strength was almost similar. Other properties were better for heartwood compared to sapwood. In case of Albizia lebbeck, all the strength properties of heartwood were superior compared to sapwood. Similarly, heartwood properties of the Albizia sisu are also better compared to sapwood, except MOE and impact bending values. So in these species, the sapwood is found to be on the average weaker than heartwood, though the difference are not always significant, but most of the properties were, heartwood properties were better than sapwood. So that is why heartwood of these commercial timbers are much in demand because the heartwood is naturally durable also, and its properties are also comparatively better. Here you can see in the swelling property of the sapwood and hardwood. It has been compared. In long term, we can see the sapwood swelling is higher compared to hardwood. So sapwood swells and sinks more as compared to hardwood. And similarly, the water absorption properties of the sapwood. Here, sapwood absorbs slightly more water compared to hardwood, because hardwood contains certain chemicals and waxes, and because of oils also. So because of that, the hardwood doesn't absorb as much water as the sapwood. And these are the similar comparison has been made for some few other wood species like eucalyptus and poplar and red pine and Scott pine. These have been published by different groups. So here we can see this is for the modulus of elasticity for the sapwood and hardwood of the four different species, eucalyptus, and so most of the cases we can see that there is a significant difference between the modulus of elasticity in case of eucalyptus, in poplar, red pines, all the pines. And we have the compressive strength parallel to grain. Here, except in case of eucalyptus and poplar, the pines, there is a significant difference between the sapwood and hardwood of these species. Similarly, the shear strength values of the sapwood and hardwood, we can see there is a significant difference between the sapwood and hardwood. Most of the cases, the properties are better for the hardwood. And this is the tensile strength values. These are the mechanical properties which are generally required for determining the end use of wood. These are the dynamic impact bending strength values for the sapwood and hardwood. These are also, we can see there is a significant difference between these two types of woods. And these are the hardness values which has been seen here. This is also, there is a significant difference in case of radial, tangential, and longitudinal. The hardness can be determined in all the three directions of the wood, and in most of the cases there is a significant difference, except in case of red pine. There is not much difference. Otherwise, in case of other pine, Scott pine, there is a significant difference. So based on these tables, we can conclude that mechanical properties with the statistically significant difference between sapwood and hardwood, like static bending strength for all the trees, there is a significant difference. Modulus of elasticity for all trees, compressive strength for all trees, and shear strength for all trees except the eucalyptus. Eucalyptus, there was not much difference. So tensile strength for all trees, dynamic bending strength, it was also different between the sapwoods and hardwood. The difference was significant. And hardness, except the red pine, these hardness values were also significantly different. So the difference between the mechanical properties of sapwood and hardwood of these tree species are statistically significantly different. Now we will be wondering whether hardwood and sapwood, any chemical difference is there. Yeah, this has also been seen that not much significant difference was found between when we see the chemical, except the extractive substance. We can see in case of oak 1.26 percentage, whereas hardwood contains the higher amount of extractive 3.35. Similarly, for other woods also, the hardwood contains a higher amount of extractives, whereas holocellulose and alpha cellulose, not much significant difference was there. Whereas pH also for hardwood and sapwood, not much difference was found. Here, the sapwood, hardwood, as well as the transition zone, all the three zones, the chemical constituents were determined. So, see, lignin was 32.4% in case of heartwood, whereas in sapwood it was 30.9%. And in transition zone, the values were in between these two extremes, like sapwood and hardwood. So transition zone, because it is a gradual change from the hardwood to sapwood, so the values were almost lie in between the values of the hardwood and sapwood for all the different chemicals. So we can see as a summary that sapwood contains much higher amount of moisture compared to hardwood in most of the trees. So when we want to season, sapwood seasoning of the sapwood is much easier compared to hardwood, because the permeability of the sapwood is also better, and the movement of the moisture is better in case of sapwood. But the amount of moisture which is present in the sapwood is higher compared to hardwood. And sapwood also contains higher amount of sugars and starch, and therefore it is less durable compared to hardwood, which is more durable because of the presence of the extract tips in it. And sapwood is lighter in color compared to hardwood, because there are extractives are present in the hardwood. And but in both the cases, because sapwood strength more or less slightly is lower compared to hardwood, but because of the presence of the extractive content in the hardwood and no extractives in the sapwood should always be treated with certain chemicals, like it is called the preservative treatment, and should be seasoned if you want to make use of the sapwood just like hardwood. So these are the different properties of the sapwood and hardwood of different species. So it depends on the tree age and the tree species and the growing conditions. So many different factors are there. So it is very much specific, and particularly for the valuable species, we should know that amount of hardwood which is present, and that is why this kind of non-destructive tools are very much required to use. So thank you very much for your attention.